This video demonstrates how to conduct the large deflection nonlinear structural analysis using ANSYS Workbench. The main objective of this analysis is to study what will be the difference in the result when the large deflection is considered. This video also demonstrates the interface between the solid and shell elements. You can observe the body which is deforming is made up of solid elements and a cylindrical bush member which is pushing the body is made up of shell elements. What kind of contact need to be considered? What are the necessary contact settings that need to be done for this analysis are also being discussed in this video. Let us look at the difference that is going to happen when the large deflection is considered. It can be observed in the result fringe plot that the deflection, that is the total deformation which is happening on the body, is 20.5 millimeters approximately. But whereas if the large deflection was ignored, that is, you can observe only 18 millimeters of deflection, that is, the total deflection in millimeter can be observed. We'll discuss why this difference happens when we consider the large deflection and when we ignore the large deflection. Let us consider a body which is having certain length, width and height and has a cross-sectional area which is fixed at one end and is applied with a magnitude of force at the other end, let us say 100 Newton. Then, if we see the side view of the body, it looks like this. When we try to solve this problem in ANSYS, ANSYS will ask for the time stepping, which means how gradually this load need to be applied. Let us say if we enter the time step to be 100, then it is going to divide the load 100 Newton divided by the 100 steps. That's equal to only 1 Newton force, which means ANSYS is going to apply the only 1 Newton force on this body. At that time, we can observe that the body will be deformed in this way. This deformation has happened because of 1 Newton force. When the geometry has deformed, it has a new geometrical properties and a new geometry stiffness. The geometrical stiffness only when a 1 Newton of load is applied. I repeat, the geometrical stiffness when only a 1 Newton of load is applied can either reduce or may increase. Similarly, when 1 Newton force is applied on the model will be solved for the equilibrium. If the ANSYS can solve it for 1 Newton force, then it will proceed with a 2 Newton force. At that time, the body is going to deform again. This deformed body will have again updated stiffness properties of the geometry or the updated geometrical properties, that is, the updated area moment of inertia and so on. This updated stiffness can either reduce or increase when the load will go on increasing and as the deformation go on increasing. This behavior or this phenomena will be captured when we consider the large deflection analysis. The large deflection analysis either may give the increased deformation or stress, or it may give the reduced deformation or the stress. It again depends upon how the member is behaving to the particular loading condition. Having understood the concept of large deflection, let us proceed with the tutorial. Create a new static structural analysis file. Make sure the series of the file is C. Rename the file as large deflection of, which means we are going to conduct first the geometrically linear analysis, then we will be proceeding for the geometrical nonlinear analysis. Pick on the engineering data. Let us include two different materials. Right-click, pick on Edit. It can be observed that the structural steel is the default material. To include a different material, let us proceed for the engineering data source. Pick on the general materials. Under general materials, choose the material that is polyethylene. Pick on this golden color plus mark to add the material into the current project. Once the material is included, you can find the symbol. Pick on Engineering Database Off. Pick on Return to Project. Now we have two different materials which are included in the analysis. Pick on the geometry. Right-click, press hold. Pick on Import Geometry. Pick on Browse. We can observe that the large deflection step CAD file is already there in the temporary memory. We can make use of the same file. You can observe a tick mark, which means a geometry is being loaded. Pick on the geometry, right-click, press hold, pick on Edit Geometry. This will open the Design Modeler. In the Design Modeler, we need to ensure what is the unit system we are going to make use. This is millimeters. Click on OK. We know that the geometry is already loaded, but it is not yet imported. Click on the geometry, click on Generate. How do we know that this particular file need to be generated? We can observe the tick mark beside the features which are present in the tree outline. But just beside the import, we can find one symbol which is other than the right tick mark, which means that requires the generation or the update. Click on Generate. The geometry is now imported. Observe the geometry very carefully. The body is a solid body and the pushing member is a surface body. How do we recognize these two bodies? Click on the parts. You can observe the large deflection, the first body, is highlighted in the solid mark, and the second body of the large deflection is highlighted in the surface symbol. We know that in the analysis there is going to be the contact which is coming in between these two bodies. That's the reason we need to define a surface split so that only a local area of this continuous surface, I repeat, the local area of this continuous surface will be used for the contact detection. Click on Tools. Click on Projection. Under the edges, click on this particular edge. Ensure that it is highlighted in the green color. Click on Apply. Click on the target. It will ask to select the face. Ensure that the face is highlighted and click on this face. Click on Apply. You can observe again the Generate symbol which is present just beside this projection. Click on Generate. It can be observed that the continuous surface has got split into two different faces. Let us also understand one of the key observations, that is, the surface body and the solid body are at a distance of 0.5 millimeter apart. This is because we are going to enter the thickness of 1 millimeter to the cylindrical body, so that 0.5 millimeter thickness will be offset on the either side of this surface. Click on Save. Let us proceed to the project page now. Click on the project page. Click on the model, right-click, click on Edit. Now we are going to conduct the structural analysis for these two bodies. The moment we enter the mechanical window, click on the View, click on the Windows, say Reset Layout. Click on the geometry. We can observe that the question mark which is highlighted, which means the surface body which is there here requires a thickness assignment. Click on the thickness, enter the thickness as 1 millimeter, enter. Now the geometry is updated with the tick mark. The next step is to assign the material. Let us say for this body we are going to assign the material as polyethylene. Pick on the second body. Let us assign the material for this as structural steel. Once the material is assigned, let us proceed to define the contact. Pick on the connection, right-click, press hold, pick on insert, pick on the manual contact region. Unless we define the contact between the two interacting bodies, the ANSYS is not going to detect the contact. We can observe here the default contact which is included is bonded, but we have to change it to the frictional contact. That's the reason under the definition, pick on the type as frictional. Enter the coefficient of friction as say 0.1. Enter. Pick on the contact which is highlighted in yellow color, which means the definition of the surface is pending. Pick on the contact. Select the top face for the contact, or this can be made use as a target. Let us make use of that face as a target because this pushing body is going to touch that body. Pick on the target and pick on apply. Now pick on the contact. Select the top surface. Pick on apply. Now we can observe that the contact shell face need to be defined. Let us say top. Let us check what is going to happen. When the contact interface is happening, the normals of the contact should oppose each other, which means when I pick on the bottom instead of top, you can observe the red surface or the contact surface is in the same direction of the target surface, which means the shell normals are inwards. That is the reason why the contact shell face need to be taken top. Now, whatever the shell normals are there that are opposing the target normals, it is not mandatory that we need to keep it always top. It depends upon the problem and varies with the problem. Once this contact definition is defined, let us proceed for defining the mesh. Carefully observe the considerations that will be done in the mesh. Right-click on the mesh, pick on insert, pick on sizing. Ensure that the solid body is highlighted here and pick on this body. Pick on apply. Enter the element size as 5 mm. We want to have two number of divisions on this edge. Pick on the mesh, right click, insert, pick on sizing. Ensure that the edge is selected. Pick on the first edge, pick on the select edge, second edge. While doing the multiple selection, make sure that the control button is press hold. Pick on apply. Enter the number of divisions over here as two number of divisions. Now right click on the mesh, pick on insert, pick on sizing. Select this edge. Also select this edge. Similarly, the other side edges. Pick on apply. We want to have the number of divisions for those edges as 10. Which means we are going to do the fine meshing at this body so that the contact will be detected smoothly. Pick on the mesh. Select edge surface of this body. Right click, pick on generate mesh. We can observe this particular body is meshed with hex elements or the hexagonal elements. Similarly, pick on this body. By selecting the body here, pick on this body, right click, pick on, generate mesh on the selected bodies. We can observe the mesh is created, but it is not a mapped meshing. That's the reason why we have to do the mapped meshing for the cylinder. Pick on the mesh, right click, pick on, insert, pick on the mapped face meshing. Pick on these two faces, pick on, apply. Now pick on this body, right click, pick on, generate the mesh on the selected bodies. Pick on the mesh here. We can observe the mesh is now systematic compared to the earlier case. The next important step is to know what is the status of the contact, which we defined just now. Pick on the connection, pick on, right click, insert, pick on the contact tool. The contact tool is open in the worksheet. The contact selection, pick on all the contacts and pick on add. The contact side, pick on the contact here. Pick on apply. We can observe the name of the contact which is included in this contact tool. Right click on the contact tool, pick on insert, pick on generate initial contact results. Let us understand what is there in this initial information. We can observe that the contact is inactive. This contact is inactive because the behavior of the contact is not updated. Pick on the contact, pick on the behavior of the contact that need to be asymmetric. Now evaluate the initial information. After the evaluation, we got the yellow color for this contact, which means this contact status is open, but it is not inactive. We can observe that the gap is 0.54102. Now, for the analysis, the static structural analysis, if the equilibrium of the forces has to happen, then this gap need to be closed, which means for any static structural analysis, the bodies must be in contact or they must be having a very negligible interference so as to transfer the forces into the interacting bodies. That is the reason why we can observe the gap here, the 0.54. We know that there exists a gap between the two bodies. That is, right click when we view in the front view, we can observe here there is a gap of 0.5 millimeter. Even though we have entered the thickness of the body as 0.5, and in the mesh, even though we can see that these two bodies are touching, the shell thickness effect is not taken into the consideration, which means the surface body is lying exactly at the center of the thickness of the cylinder. To give the thickness effect, to detect the contact, we need to enter a command, the ANSYS APDL command for this contact. Pick on this contact, right click, pick on insert, pick on the commands. Now the window is open. Enter here key point option, comma, contact ID, comma, 11, comma, 1, which means the 1 represents the shell thickness effect on, and if it is 0 instead of 1, it is going to be shell thickness effect off. Once we define this command for this particular contact, now pick on the initial information, right click, pick on generate initial contact result. Because of the shell thickness effect, we can observe that the gap has been reduced to only 0.04. But for ANSYS, this gap also is not valid for obtaining the equilibrium of forces. Pick on the gap, copy this magnitude, and pick on the respective contact where this gap is present, that is over here. We can observe and we can claim that the gap existing is 0.5, and we have given the thickness for the body as 1 millimeter, that is 0.5 millimeter up and 0.5 millimeter down. Still, why this gap is present? This gap will be inherent. That may happen because of the accuracy change or the meshing. To proceed further, pick on this frictional contact and under the interface treatment, pick on the interface treatment, pick on adjust to touch, which means it will adjust that much of contact or the gap. To be more precise, front view, we can see the mesh. Even though we can find that these two bodies are touching, there exists a very minor gap of 0.04. That much of amount a contact surface will offset to detect the initial contact. Now, let us proceed for defining the load and boundary conditions. Pick on the static structural, right click, pick on insert, pick on the fixed support. Pick on the bottom of the body, pick on apply. Right click on the static structural, insert, pick on the force. Pick on the bottom face of the cylinder, pick on apply, enter the magnitude of force in the y direction as 12 Newton. We need to define the boundary condition for this body. That's the reason why right click on the static structural, insert, pick on the displacement. Select the top surface and pick on apply. The surface or the body with respect to the surface has to translate in the y direction only. It is not supposed to translate in the z axis or the x axis. To constrain that, pick on the x and z is equal to 0. Once the load, boundary conditions and the contact are defined, let us proceed for the necessary analysis settings. The 12 Newton force is applied, but this force need not have to be applied at once. This has to be applied in steps. That step we are going to define in the analysis settings. Pick on analysis settings. The automatic time stepping need to be replaced by defining the new time stepping. Initial, let us say 50, minimum 20, and maximum say 100. After the analysis setting definition, right-click on the solution, insert, pick on the deformation, pick on the total deformation. Let us cross-check the model. The thickness are assigned, the contact is defined, and the mesh is also defined. The mesh settings also were done. Loads and boundary conditions are defined. Desired results are also taken for the analysis. Right-click on the solution, pick on Solve. This solution is without considering the large deflection effect or the geometrical nonlinearity. The solution is in process. This is the geometrically linear analysis. After the solution, we are going to proceed with the geometrically nonlinear analysis. Pick on the deformation. We can observe here that the contact is not detected between two bodies. Why this has happened? Even though we defined the contact, even though we have closed the gap, even though the contact settings are done, this contact was not detected. That's the reason why. Let us go back to the contact settings again. Under the detection method, the contact detection method, pick on Add node normal to target. Pick on node normal to target. Now run the analysis. Right-click, pick on Solve. The solution process is under progress. Pick on the solution information. Pick on the force convergence. This is the force convergence graph which can be observed for this analysis. We can observe the percentage of solution: 51%, 61%, 66, 81%, 86%, 91%, 96%, and the solution is completed with some warning messages. Pick on the total deformation. Enter 1:1 scale here. View the front. We can observe that the contact is perfectly detected between the bodies. Switch on the mesh for this result. Pick on Show Elements. This convergence was obtained and the contact was detected. But this is geometrically linear analysis. Let us proceed for the geometrical nonlinear analysis with keeping all the loads, boundary conditions, geometry, materials, contact settings the same, but by changing only the analysis setting. Pick on File, pick on Save Project. Go back to the project page. We have solved the large deflection of analysis. Right-click, pick on Duplicate. This is going to be the series D. Rename the file as Large Deflection on. Pick on the solution, right-click, pick on Edit. In this, we are going to make the setting to capture the large deflection effect or the updating geometry stiffness effects. Pick on the view, pick on Windows, pick on the reset layout. All the settings are the same. Just pick on the analysis settings and make here the large deflection on. Now, ANSYS will capture the changing stiffness of the geometry for each iteration or for each load applied. Pick on the solution, click on solve. The solution is in process, which can be observed from the ANSYS Workbench solution status. Pick on the force convergence, solution information, force convergence, 36%, 46%, 51%, 56%, 60%, 65%, 69%, 74%, 77%, 80%, 84%, 89%, 92%, 96%, we can observe the problem was solved for 100%. The key observation we need to note here is when we do the large deflection analysis or geometrically nonlinear analysis, the computation time involved is higher compared to the linear geometrical analysis because ANSYS takes time for the computation of the large deflection or the geometrical stiffness changing effect into the calculation during the solution process. We can observe that the total deformation observed in this model is 20.5 millimeter and initially it was only 18 millimeters. Hence, by this study, we can conclude that the large deflection analysis study is more realistic compared to or in comparison or in relation with the real world examples. To evaluate the reaction force, pick on the solution, right click, pick on insert, pick on the probe, pick on the reaction force here. Because we have applied the force from the bottom and that reaction force we want to check at the fixed support. Right click, pick on, evaluate all the results. In the Y direction, if we evaluate the force, we can observe here 11.888 force, which is equal to the applied force of 12 Newton. By this, we can say that the solved problem is correct because whatever the force that was applied on the body is being replicated or negated by the reaction force which is happening on the fixed support. Let us plot the deformation for the large deflection on-off problems. First, let us go to the large deflection of problem. Right click on the solution, pick on insert, pick on the deformation, pick on the directional deformation, that is y-axis. Right click, pick on evaluate all the results. We can observe the maximum displacement which has happened. Copy the column. Go for the Excel file. Paste the deflection results here. This is for off. Paste. Now go back to the analysis page with the large deflection on. Pick on solution, right click, pick on insert, deformation, pick on the directional deformation in the y-axis. Right click, pick on evaluate all the results. Under the tabular data, pick on the maximum value. The whole column got selected. Copy this column. Right click, copy cells. Go to the Excel file and paste in large deflection on. Let us plot the graph for these two. Pick on insert, pick on the chart. Let us use this 2D chart. Right click, pick on the selected data. Add, pick on the series values as these values. Pick on the series name as off. Pick on OK. Now pick on the add. We'll say here the large deflection on and the series values will be this. When we compare the large deflection effect off and large deflection effect on, it has taken the more computation time and more steps to solve, whereas the large deflection effect off problem has deformed less and has taken a less time. Thank you for watching this video. For more videos, please visit my channel, or you can pick on the subscribe button for my new videos. The subscribe button is just below this video. If you are interested for the online training and the mechanical engineering projects, you can please send me an email to engineeringtutorsdesk@gmail.com, or you can use my Skype ID for any communication. You can visit my website for more tutorials on ANSYS Workbench, Hypermesh, LS-DYNA, and Creo Parametric. Thank you.